Bismillahirrahmanirrahim. Sallallahu alayhi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wasallam. Ameen. Alhamdulillah rabbil alameen. Complex numbers, lecture 7. This is the advice for me and for everyone. Speak well or don't speak. Well, rotation in complex numbers. 90-degree clockwise rotation. For 90-degree clockwise rotation, you need to multiply the given complex number by minus I. So make sure you multiply the given complex number by minus I for 90-degree clockwise rotation. For example, if u is 3I and then for 90-degree clockwise rotation of u about the origin, you need to multiply u by minus I. Like minus IU, therefore it will become minus I times 3I and the final answer is 3. And according to sketch, this you can easily understand this thing. So this is 3I. When you will rotate this 90-degree clockwise about the origin, then you will get 3. 90-degree anti-clockwise rotation. This is obvious. For 90-degree anti-clockwise rotation, you need to multiply the given complex number by positive I. So make sure you remember this thing. You need to multiply complex number by positive I. For example, if this is the complex number u is 2 and we have to rotate u 90-degree anti-clockwise about the origin, therefore we need to multiply I with u with I. So it will be 2I, and this can be proved through this diagram. This is u. So when you will multiply u with I, you will get 2I. This is 2I, and this is the 90-degree clockwise anti-clockwise rotation about the origin. Now, I will discuss the solutions of some important questions in this lecture. Question number 1. This is the question of November. Now, let me show you the list of the questions. This is the list of the questions. So, the first question is November 2009, variant 3-1. Question number 1. This is given. U is minus 2 plus I. Given that u is a root of the equation x cube minus 11x minus k. Find k. So this is very simple. You just need to first simplify the equation. Like by taking x common from these two, you will get x times x square minus 11 is equal to k. Now you can easily substitute u. So by substituting u here and here, we can easily get k. So remember, don't substitute u over here in this equation because it will be very complicated to simplify the equation because power cube is not easy to expand. So first take common, make the equation simple, and then do this substitution. So by solving this equation, we can get the value of k, which is 20. Well, the second part of this question is write down the other complex root of this equation. You all know complex roots always exist in pair form. So if this is the first root, then it's the second root will be the conjugate of this root, meaning the second root must be minus 2 minus I. Find the modulus and argument of u. So for modulus, you need to take the magnitude of the complex number. So the magnitude of the complex number is under root 5, and for argument, always make a sketch. This complex number is here, therefore its argument must be this angle. First, get the value of alpha. Alpha is 1 upon 2, tan inverse 1 upon 2. So alpha is 26.6, therefore the argument of u is 153.4. And make sure you write argument by small a. This is small a. We use small a for argument, and it must be one decimal place in degrees. This is also small a. Now the last part of this question, we have to shade this inequality and this inequality. We have to, this is the perpendicular bisector, and this is the argument z from u. We need to shade the required region. So this is the perpendicular bisector of 0 and 2. The midpoint of 0 and 2 is 1. So here is the perpendicular bisector. Since this inequality is towards 0, therefore you need to shade this side of the bisector. Well, you have to draw the line of argument from minus 2 plus I. This is minus 2 plus I. And since there are no equal signs here, therefore this line should be broken. This line should be broken. And the angle is pi by 4. And you know how to draw pi by 4? For pi by 4, you go 2 units right, therefore you are going 2 units right, therefore you have to go 2 units up. We draw pi by 4 in this way. If we are going 1 unit right, then we must go 1 unit up. This is for pi by 4. So since we are going 2 units to the right, therefore we have to go 2 units in upward direction. And you need to mention this intercept. The line must pass from 3. Therefore, since angle lies between 0 and 45, therefore this will be the required shading for this argument, and this was the shading for the perpendicular bisectors. Therefore, we have to take the common region, and the common region is mentioned in black color. This is the common region. Now, question number 2. In this question, we have to first find u plus v, then we need u upon v, and then we need argument u upon v. So the first part is very simple, u plus v. You just need to add the like terms, like real part with real part, imaginary with imaginary. This is u plus v. And in u upon v, you need to rationalize this complex number. And you know, we rationalize number from the denominator. We multiply and divide this fraction by the denominator with opposite sign, by the expression of denominator. So in denominator we have 3 plus I, so we need to multiply this entire fraction by 3 minus I over 3 minus I. In fact, multiply and divide. This is the way we rationalize the complex number fractions. You just need to simplify this carefully. So you know how to rationalize this. You just need to multiply minus 2 with this and then I with this. In denominator you will get a square minus, in fact, b square. In complex number we get this formula, a square plus b square. So initially I wrote a square minus b square because most probably you are not used to with this. So you know I square is minus 1, therefore it will become 3 square plus 1 square. So this will become 10. You can use do in any way. So in denominator you have a plus b, a minus b, and the simplified form of the denominator is this, and the numerator is this. We always break the LCM because we give the answer in this form, a plus bi. Now the next part is state the argument of u upon v. This is very simple. This line is y is equal to minus x. This is minus half plus half I. So this is y is equal to minus x. So its argument must be 3 pi by 4. Next part is show that AOB is 3 pi by 4. This is very simple. This is the Argand diagram. Make sure you write real part of z here. You must label this axis as real part of z, and this is his imaginary part of z. This is the way we label the Argand diagram, the axis of Argand diagram in fact. So this is A, this is B, and this is C, and we need AOB, we need this angle. For this angle we just need to write argument A minus argument B, and please use small letters for argument. Argument B minus argument I'm sorry, argument A minus argument B. And you know A is U and B is V. So you will write A is U, substitute A by U and substitute B by V. Therefore, this will be AOB is argument U upon V, and you have done argument U upon V in the previous part. This is argument U upon V. It's 3 pi by 4. So you can copy your answer here. Argument U upon V is 3 pi by 4 shown. Now the next part is state the geometrical relationship between OA and BC. So you just need to use vectors. To get BC, you should write OC minus OB. See, this is the way to get BC. Use head to tail rule. You have to go 2 units left and 1 unit in upward direction in order to get BC. So BC is minus 2 plus I. So by using vectors, you can get BC. And if you check A is also minus 2 plus I. Therefore, since they both are equal, therefore OA and BC are equal and parallel. This is the way to mention the relationship between the complex numbers. Sorry. Question number 3. The complex number 2 plus 2i is denoted by u. Find the modulus and argument. This is very simple. This is y is equal to x. 2 plus 2i is on y is equal to x. Therefore, its argument must be pi by 4. And its modulus is very simple. Just take the magnitude of the numbers. Now we have to sketch the Argand diagram of this and this. This is the perpendicular bisector and this is the circle. So, circle with radius, with center at u, and u is 2 plus 2i and radius 1. So, here is the circle with center at 2 plus 2i and radius 1. And bisector of 1 and I. Well, this is 1 and this is I. Don't need to mention I and 2i here, just write 1 here. It's not required to write I here. It's obvious this is I. So this is 2. Just write 1 and 2 and 1, 2, 3. Don't write I here. Just write 3 here. Well, the bisector of 1 and I is this line. This is the perpendicular bisector of 1 and I. According to first, this loci, this locus, you need to shade the side of one of bisector, and according to this inequality, you have to shade the inside the circle. So this bisector has two sides. This is the side of one, and this is the side of this is the side of I of bisector, and this is the side one of bisector. So you need to shade this side. And then this is the circular part. I mean, you need to shade inside the circle. Now you have to take the common part, and this is the common part. So this is the final shading. This is the final shading. Make sure you shade the required region correctly. Now the next part of this question is, using your diagram, calculate the value of modulus z for the point in this region for which argument z is least. Well, argument z is least. Z is in this region. Z is either on the circumference or here. So for argument z least, you have to draw a tangent from origin to the circle. This is the tangent. And for argument z least, z must be here. When z is here, then this angle is smallest. So this is the position of z. It's mentioned find modulus z when argument z is smallest. So basically we need this distance, this one. We need this distance, OZ. And this is very simple. By using right angle triangle, we can easily get this distance. Since the distance from origin to center is under root 8, and this is the radius, therefore this is the right angle triangle. So we can easily use Pythagoras in this triangle to get this distance. Now this is not the shortest possible distance, this is wrong. Let me erase this. Let me change the color of the pencil. Well, this is the right answer, and let me draw the triangle here. This is modulus z, this is under root 8, this is 1, and this is right angle. Tangent is perpendicular to radius. So by using Pythagoras in this triangle, you can easily get the answer. Question number 4. Well, in this question, first we have to show the modulus of z is 2 cos theta. Show that the modulus of z is 2 cos theta, and then we have to show argument z is theta. This basically involves a lot of trigonometry. So if you are good at trigonometry, you can easily manage the calculation of this question. You must know these formulas. So z is 1 plus cos 2 theta plus I sin theta. This is given. Therefore, for modulus, we need to square this and this. Now we need to expand the first bracket by means of a plus b whole square. We'll get this thing then. And this is 1. And after the simplification and taking common 2, we have this. And 1 plus cos 2 theta is equal to 2 cos square theta. So by substituting 1 plus cos 2 theta by 2 cos square theta, we will get this thing. Finally, we have 4 cos square theta and then 2 cos theta shown. Now we need to work for argument. Well, argument is y upon x or b upon a, tan inverse. Imaginary part over real part. This is the formula of the argument. So sine 2 theta will become 2 sine theta cos theta, and this denominator will become 2 cos square theta from this thing. That is why I told you, if you are good at trigonometry, then you can easily manage these types of calculations. So finally we have, after the cancellation, we have tan theta here, and you know tan inverse and tan will be cancelled out. So finally we have argument z is theta, and for argument we use a small letter. Sorry. Now the next part is prove that the real part of 1 upon z is constant. We have to show this. The real part of z 1 upon z is constant. This is basically of rationalization question. I'm sorry. So 1 upon z, this is 1 upon, this is z, and for rationalization we need to multiply and divide this fraction with this denominator with opposite sign. You know how to rationalize this. So we just need to use a plus b, a minus b formula here. Then we'll get this thing. And since we know the value of this entire thing, see, the value of this entire thing is 4 cos square theta. So you need to substitute this entire by 4 cos square theta. And then you need to break the LCM. When you will break the LCM, you'll get half here and this thing is here. We had to show real part of 1 upon z. This is the real part of 1 upon z, and this is constant, hence shown. Question number 5. Well, in this question, we have this equation 2x cube minus x square plus 2x plus 12. This is the repetition of question number 1. We did this thing in question number 1. A similar question of this is 1. Question 1 is in fact similar to this question. So in order to substitute this, we first need to simplify this equation, because it's difficult to expand cube. Therefore, we need to take x common, in fact x square common from these two brackets, so that we can easily substitute the value of x, which is 1 plus I root 3. So by substituting 1 plus I root 3 here, here, and here, which is mentioned here, we can easily show that this is the root of this equation. A lot of calculation is involved, so make sure you do the calculation very carefully. This depends on your algebra. If you practice more, then you will be good at with this. So my advice is practice as much as you can. Now the next part. The next part of this question is, this is the circle, inequality of circle, and this is the argument of less than pi by 3. So here is the circle with center at 1 plus root 3i. Root 3 is approximately 1.7 and argument is pi by 3. So the argument of center is in fact is pi by 3 as well. If you will find argument of this center, you will get pi by 3. So they both are same. That means this argument line will pass from the center. This is the line of argument, and this must pass from the center, and this is the required region, because it's mentioned that argument z is less than equal to pi by 3. This is very simple, and argument is mentioned with small a, by small a in fact. Now this question is very simple. we need modulus and argument of z. This is very simple. You just need to find the magnitude of this complex number, which is 2, and then you need to find the argument. For argument, I have told you that make a sketch, make the argon diagram. This complex number is here, it is in first quadrant, its argument is pi by 6. Now the second part is 2z plus z steric. You all know z steric means conjugate of z. Since z is root 3 plus I, therefore its conjugate must be root 3 minus I, and this is the simplified form of 2z plus z steric. Now the next part is iz steric upon z. This is very simple. You just need to rationalize this fraction, and you know how to rationalize this. So I'm not going to discuss this because we already have done 2 or 3 questions of rationalization. But make sure you handle the calculations carefully. And this is the simplified form. Always give your answer in this form, like in this, a plus bi. Always break the LCM. Now the next part is this a is represented by root 3 plus I, and iz steric is represented by 1 plus root 3I. So this is a root 3 plus I, and this is b, which is 1 plus root 3I. Therefore, the question is find angle AOB. This is very simple. You know, this is argument iz steric. AOB is this. Subtract this from this. So for AOB, you just need to write argument B minus argument A. And argument B is iz steric, whereas argument A is Z. So according to the property of argument, when we have negative sign between two arguments, we write argument like this. Argument this upon this, and this is the property of the argument. If we have argument u minus argument v, then this will become argument u upon v. And since we have iz steric upon z, we found this in the previous part. Here, this is iz steric upon z. So it's very simple to get the argument of this complex number. It's pi by 6. Half upon root 3 upon 2 is pi by 6. So make sure you handle these type of questions carefully, because these type of questions required the knowledge of the previous parts. Question 7 is simple. Therefore, I'm leaving this question. This means circle. So you know how to draw the circle. I'm leaving this. I'm not drawing this circle. Now this is a good question. Question number 8. A very good question. This involves remainder theorem. The first part is z plus 2 is a factor of p of z. This is very simple. Just need to substitute minus 2 into this equation. Equate this equation to 0 and get the value of m. It's 6. Now find the roots of p z is 0. We have to solve this equation. For that we need to use long division. So by using long division, we have this one root. This is the polynomial equation. So this will be the quotient. Quotient means the second root, the quadratic root of this polynomial. I'm sorry, I wrongly closed the file. Yeah, so this is the quotient. The other, in fact, the quadratic root of this polynomial. So we need to solve this quadratic. Breaking of the middle term is not possible. Therefore, we have to use quadratic formula. Use the quadratic formula carefully because you have negative sign here. And you know this will become I. And these are the other roots. The second root, the third root, and this was the fourth root. So there are 3 answers. Now very important part, the last part. we need to solve p z square equal to 0. If you will observe these two equations, you will see z is replaced by z square in the last equation. This is z and this is z square. So you just need to replace z by z square in the answers of part 2. So this z is replaced by z square, this z is replaced by z square, and this z will also be replaced by z square. So we have to solve these roots, in fact these equations. Well, z square. For z square we need to take square root on both sides. So this is the solution of z square. Now this z square, this is the concept of two square roots. Make sure you remember this concept. So this will be solved by this concept, with the help of this concept, two square roots. You need to replace z by x plus iy whole square. Then you need to expand this. Then you need to compare the real part with the real part, imaginary part with the imaginary part. Since x and y both are real, therefore we need to ignore the negative value of this x. This negative value. X square is minus 3. This must be ignored because x is real. So we have two values of x. Therefore, by substituting these two values of x over here, maybe here, we'll get two values of y. This and this. This value and this value. So you need to write these as 1 plus root 3i, this one, and the other one is minus 1 minus root 3i. So 1 plus 3 root 3i is here, and minus 1 minus root 3i is here. See, we don't need to solve this root. We already have solved this root, so there is no need to solve this root because complex roots exist in pair form. Therefore, since we have got this answer, so its conjugate must be this. And the conjugate of this is this, minus 1 plus root 3i. So now count your answers. 2 answers and 4 answers. And this equation has 6 answers. This is the way to solve these type of questions. Let me show the working again. From 2 square roots, you must understand the concept of 2 square roots. For that, you should watch all my lectures on YouTube, lecture number 1 to 6. If you want to be good at this chapter, must watch all my lectures on YouTube. I have explained everything in detail, almost everything in detail. Well, this is question number 9. The first part is rationalization. You all know how to rationalize this. This is the simplified form of u, and since u is on vertical axis, on imaginary axis, therefore its angle is argument is minus pi by 2. This is u, therefore its argument is minus pi by 2. Don't need to write I here. Well, the second part is argument z minus u is pi by 4. Find the least possible value of modulus z. Okay, first sketch this. So this is argument, yeah, it's here. Argument z minus u, and u is minus 3i. So you have to make the line of argument from minus 3i. So this is the line of the argument. This circle is nothing, just ignore this thing. So this is the line of the argument, and we need the shortest distance of z modulus z, And modulus z means the distance of z from origin, and the question is find the shortest distance. So this is the shortest distance of z from the origin. You have to make a perpendicular bisector. Draw a perpendicular from origin to this line, not bisector, just a perpendicular from origin to this line, because z is on this line, anywhere on this line. So if you will drop this perpendicular from origin to this line, therefore z will be here, and you need this distance. For that, you just need to consider this triangle. This is the isosceles triangle with this length 3. So by using Pythagoras, you can easily get this distance. Right angle isosceles triangle. So this is the answer. Last part. This is the equation of circle. We need greatest possible value of modulus z. This is very simple. Well, this is the equation of circle, and this is the simplified form. This is the center of the circle with radius 1, and this is the formula of the modulus, greatest value of modulus z. To get the greatest value of modulus z, just add center. This is center. It's mentioned, center is mentioned as z, but this must not be mentioned as z. This should be mentioned as v. So this is v, center. So the formula of the greatest value of modulus z is modulus v plus r, the modulus of the center plus radius. So this is the answer. What if the question was find the smallest value of modulus z? So the formula will be modulus of center minus radius, 3 root 2 minus 1. But this was required only. This. You can watch my lecture 2 on YouTube to understand this concept in detail. I'm sorry, I think it was lecture 6 maybe, not lecture 2. Well, in this question, we have to first express u in the form. So by rationalizing u, we can express this as this. This is u. And the second part is argument u steric is 3 pi by 4. Find the value of a. So argument u steric is 3 pi by 4. So this is u steric. So its argument will be tan inverse imaginary part over real part. And by solving this entire thing, you can easily get the value of a. This is the working of part 2. Now, this is the inequality of circle. The circle should be broken. And this is the bisector of 0 and 2 plus 2i. So this is fine, but this should be broken. Like bisector should be broken, and circle should also be broken. So if you understand it is fine. This is 2, but make sure this is the bisector. And this should be broken because we don't have equal sign in inequality. So this is the bisector of 0 and 2 plus 2i, I guess. Let me check this. Yeah, it's 2 plus 2i. Well, and circle should also be broken because we don't have equal sign in the inequality. And according to this inequality, we need to shade inside the circle, and here we need to shade the side of 0 of the bisector. So this is the final shading. Make sure you shade the entire part. Well, question number 11, find the roots of the equation z square plus 2 under root 3z plus 4, giving your answer in the form. This is very simple, you know, this is the quadratic equation, so you should use quadratic formula for that and you will get these two answers. Second part, state the modulus and argument of each root. Again, very simple part, a very simple thing. You know how to find modulus, magnitude, and for argument, always draw the argand diagram. This is minus root 3 and this is 1i. So its argument is, this is pi by 6, so the argument will be 5 pi by 6. And since this is the conjugate of this, therefore its argument should be negative pi by 6, because z and z steric are the reflections about the real axis. You must remember this concept, that if the argument of z is 5 pi by 6, therefore its conjugate's argument will be negative 5 pi by 6. Signs are opposite. And modulus will be same. Now the next part, we have to solve this equation. Z power 6 is minus 64. In fact, we have to show that these are the roots of this equation. For this, use the polar form. You should use polar form. This is the polar form. You should prove this equation through this polar form. So if you will use, you have to in fact use both the roots. You have to show, the question is show that each root also satisfy this equation. So this is the first root and its modulus is 2 and argument is 5 pi by 6. So you need to first convert this root in polar form. So the first root has modulus 2 and argument is 5 pi by 6. So by substituting r2 and theta 5 pi by 6 into this polar form, we'll get this thing. And we are working for z power 6. You all know, if this is 6, then r has 6 power and this is 6 theta. I discussed these things in my lectures. So you should watch 1 to 6, lecture number 1 to 6, if you want to be good at this chapter. So I'm not going to discuss this thing in detail now. Well, this is z power 6 minus 2 minus 6, and therefore z6 is minus 64. So we have shown that this root, in fact this root satisfies this equation. Now you need to substitute the second one yourself. I'm leaving this for you. The second root was the modulus of second root was 2 and its argument was minus 5 pi by 6. Now first substitute these things here. I'm doing few steps for you. So this will be minus 5 pi plus I sine minus 5 pi. When you will solve this, you will get minus 64 shown. Both roots satisfy this equation, z power 6 minus 64. Now this is the question of 2 square root. So in this question, we have to find 2 square roots of this complex number, and this is the working. First, let this as u, and this will be u square, and then substitute u by x plus iy square, and then expand this, and then equate the real part with real part. This is the real part. This should be equated with 1, and this imaginary should be equated with this minus 2 root 6. Then you will get two equations. This is the equation number 1, and this is the equation number 2. Now solve these two equations simultaneously. Ignore the negative value because x and y both are real. Therefore, these are the possible values of x. By substituting these values of x into equation 2, we can get the values of y. And these are the two square roots. Plus minus root 3 minus 2i. You can write them separately or you can write them like this, as you wish. You can write them as the possible square roots are this and this. These are two possible square roots. Question number part B. Part B is circle, inequality of circle. Find the greatest value of argument z. This is very simple. You know, for that you need to draw a tangent. Draw a tangent from origin to this circle, and here z must be here for argument z greatest. Get alpha and add 90 into alpha for argument z greatest. So alpha is 0.73, add 90, the final answer is in degrees 131.8, in radians 2.3 something. I'm not sure, I think it's 2.30 maybe, I'm not sure. You can check in this in your calculator. This must be up to 3 significant figure. This is not right, 2.3. Please check this answer yourself. This, I think it's 2.31 or 2.30. In radians, give your answer in up to 3 significant figures. Well, in this question, we have this complex number w. The question is find a modulus and argument of w square and w cube. So this is very simple. This is the way to get w square. Now make the sketch for, make the Argand diagram for w square, and according to this Argand diagram, the angle argument of minus 2i is minus pi by 2. So its argument is minus pi by 2, and w cube can be found by writing w square into w. So by multiplying w square with w, we can get w cube. This is w cube. This is on y is equal to x. Therefore, its argument must be pi by 4, and its modulus is under root 8 or 2 root 2. So this question is very simple. Now second part, they are saying w and w square are the endpoints of diameter. Find the equation of circle. This is a very simple question. It's mentioned w and w square are the endpoints of the diameter. Therefore, center is the midpoint. So first get the midpoint of w and w square. This is the midpoint of w and w square, and this is the coordinates of center. Now, you know, this is the diameter w and w square. So first find w square. So w square can be found like this, w square minus w, by using vector method. So this is w square. The now get the distance of length of this under root 10. This is the length of diameter. You know, radius is half of diameter, so this is the radius. Now this is the equation of circles. Substitute center here and radius here. Let me show the working again. So this from part 2, in fact. First get center by taking the midpoint of w and w square, and then get the distance of w square, and then half the distance to get for radius, and then you can easily get the equation of circle. Well, first part is simple. I'm leaving first part for you. The second part is equation of circle. You can draw the circle yourself. I'm leaving this for you. Now 15, first part is simple. I'm leaving this for you, rationalization. And the second part is show on a sketch u 1 plus 2i 1 minus 3i. This is 1 plus 2i. This is 1 minus 3i. And this is u, I guess. I think u was minus half plus half I. Minus half plus half I. Let me check this. A is u. Yeah, exactly. Now, by considering the arguments of 1 plus 2i and 1 minus 3i, show that this thing. We have to show this by considering the argument of these two. So, let me check this here. See, 1 plus 2i, 1 minus 3i. This is B and this is C. We will use that in information. Let me write that information here. U is 1 plus 2i, 1 minus 3i. And if you will observe this, so this is B, whereas this is C. So you can write, and you know, the simplified form of this is minus half plus half I. So you basically need to equate these two things. See here. Well, argument B is tan inverse 2 and argument, in fact, you can leave this part as well. It's fine. Argument B is tan inverse 2. Argument C is minus tan inverse 3. Why? Because if you will observe B and C, the argument C is negative tan inverse 3 and argument B is tan inverse 2. So, I'm sorry. Yeah. So, argument B is tan inverse 2. Argument C is minus tan inverse 3. And you know, argument U is equal to argument B upon C. Why? Because tan inverse 1 plus 2i upon 1 minus 3i. Because of this thing. Because this was U. And this is basically B. And this is C. So argument U is equal to this. And this is equal to tan argument B upon C. Let me repeat this. This is complex number B and this is the complex number C. So that is why I wrote B here and C here. And this is U. That is why I wrote argument U here. Make sure you understand this step carefully. Now, argument U is 3 pi by 4. How do I know argument U is 3 pi by 4? See here. This is U. Therefore, its argument must be 3 pi by 4. If you will plot this complex number, you will get 3 pi by 4. So, argument U is 3 pi by 4. And this can be written as tan in argument B minus argument C, according to the property of argument. And which can be written as tan inverse 2 because argument B is tan inverse 2, it's mentioned here. And argument C is minus tan inverse 3. So tan inverse 2 plus tan inverse 3 is 3 pi by 4. This is a way to show this. This is one of the most important part of this question and in fact this sheet, this worksheet. Question number 16. First part, we need to solve these two equations simultaneously for U and W. So by solving these two equations simultaneously, we can get W and U. So I substituted U from equation 1 into equation 2. and I got this quadratic equation, and then I use quadratic formula, and I got two values of w, and I simplified b square minus 4ac here. To make the step simple and calculation simple. So these are two values of w and these are two values of u. This is the way to solve this type of equations. Second part. Now this is one of the most important loci. This is circle, inequality of circle, inequality of negative pi by 4, loci, argument, negative pi by 4, real part. Real part means x greater equal to 1. So, circle with center 2 minus 2i is here, and argument 2 minus 2i. Let me check this. Argument is minus pi by 4 and modulus is under root 8. The argument of center is minus pi by 4 and the modulus of center is under root 8. This will help you to solve the last part. This is x greater equal to 1 and this is argument less than minus pi by 4. Argument z minus pi by 4. So if this is minus pi by 4, then you need to shade this part. Is less than. So you need to shade, exactly, you need to shade this part because less than means less than minus 45, like minus 60, minus 80, these things. So let me repeat this thing again. First, inequalities of circle with center at 2 minus 2i, with modulus of the center is under root 8 and argument of the center is minus pi by 4. The second one is locus of argument, which is minus pi by 4, a line of minus pi by 4, which with this part is required. And the third one is x greater equal to 1, the horizontal line. And this line should not be broken because it is greater equal, so this should be solid line. And if you will check the required region, this is the required region, because this line says you need to shade this part. According to inequality of circle, shade inside the circle. According to this argument, you need to shade this side, and according to this inequality, you need to shade this side. Therefore, this is the required region, and z must be here for real part of z greatest, and this is the real part of z greatest. Now, how to find this real part of z greatest? This is very simple. You just need to use triangle. Consider this triangle here. We need this distance, real part of z. Since this angle is pi by 4 and this is 2 plus 2 root 2, because the length from origin to center is 2 root 2 and this is radius. So the total length will be 2 plus 2 root 2. Therefore, by using cos in this triangle, we can easily get real part of z. Repeated question. Like first part, this is similar to question 1's first part. You just need to check this is the root. For that, you need to take x square common from these two, and then you can easily check this. So I'm not solving this question. The second part is 2 square root. 2 square root is very simple. We already have done a question of this type. Find the 2 square roots of px0. So find the other root, not 2 square root, find the other roots. So this is the first root and its conjugate will be the second root, So we have two roots, 1 minus root 2 and 1 plus root 2i. So use these two roots and get a quadratic root. So by using these two roots, we can get this quadratic root. Now use long division and get the second quadratic root. And then use quadratic formula onto this root. By using quadratic formula, you can get this answer. X square plus 2x plus 2. So x is equal to minus 2 plus minus, I think this must be, not sure, b square 4, 8 minus 4. This is 2. So minus 1 plus minus I. This is the way we got these two answers. Well, this is the last question for this lecture. Without using a calculator, solve this. This is very simple. You just need to simplify the first right hand side, get the simplified form of right hand side, then cancel these two i's, and then you can easily get w, and w is 2 root 2i. The second part is sketch the Argand diagram, inequality of circle. This is the greatest and least values of modulus, and this is the greatest and least values of argument. A very simple question. So here is the circle, and with center at 4 plus 4i and radius 2. Now for greatest value of modulus z, z must be here. This is the greatest value of modulus z, and for smallest value of modulus z, z should be here. Modulus z means distance of z from origin. So this is the distance of z from origin, and this is the smallest distance of z, and this total is the greatest distance of z from origin. So this is very simple. You just subtract. See, you need this distance. So the radius is 2. So 4 root 2 minus 2. And what is this 4 root 2? This 4 root 2 is the modulus of the center. So the formula of the greatest distance, formula of the greatest distance is modulus of the center. Formula of the shortest distance, smallest distance, is modulus of center minus radius, and this is modulus of center plus radius. This is the modulus of center. Now for argument, you need to draw tangents. This is the least value of argument, and this is the greatest value of the argument. And for that, you need to get the argument of center. This is the argument of the center, this, which is pi by 4. I don't know, I have to do this in degrees or radians. Radians. So this is pi by 4. Now get this angle x. Use this triangle for that. You can get this angle x as, this is 90, this is 4 root 2, and this is 2. So you can easily get this angle x by using sine in this triangle. And this x is 0.361. Now this alpha is pi by 4 minus x, and this beta is this angle. So beta is pi by 4 plus x. Here is the answer of alpha, and this is the answer of beta. This will be the last question of today's class, because this is one of the most important questions. That is why I'm discussing this question now. I'm leaving first part. First part is very simple. You just need to substitute w by a plus bi, and then you just need to equate real part with real part, imaginary with imaginary. See, w is this, w static is this. We equated real with real, imaginary with imaginary. Then we got two equations, and we then solved those equations simultaneously. Then we got b is minus 2 and a is 7. So this is the answer of the first part. The first part was very simple. Now this is the argument from 2i and this is the bisector. So this is the bisector. I'm sorry. Question number 19, I guess. Yeah, this one. So this is the perpendicular bisector of 3 and 3i. And this is the argument line from 2i. It's mentioned here. Argument from 2 and the angle is pi by 6. Now this is the point of intersection, and we can get this point of intersection by solving these two equations simultaneously. And equation of this line will be y is equal to mx plus 2, and you know m is tan theta and theta is pi by 6. Therefore m is tan pi by 6, which is under root 3 upon 2. I think I'm sorry, it should be a 1 upon root 3. Tan pi by 6 is 1 upon root 3. So the equation of this line will be 1 upon root 3x by n plus 2. So this is the equation number 2 and this is the equation number 1. You just need to solve these two equations simultaneously for p. So these are two equations, solve them simultaneously. So by solving these two equations simultaneously, you will get x this, y this. This is p, and its modulus will be 6.69, and its argument will be pi by 4. And this is the exponential polar form. You just need to put r here and theta here. Because this is theta, it's mentioned here, and this is r. So this is the final answer. So I'm ending this class here, and this will be enough for the students who have done complex numbers or who will do complex numbers. These questions will be enough for them to understand this chapter. Think before you speak. This is the advice for me and for everyone. And inshallah, when I will get time, I will make another lecture of complex number to cover the remaining questions. Inshallah. Good luck and practice as much as you can. Maths is the combination of detailed concepts and regular practice. You should be regular with your studies, and if you work hard, then you can learn anything. Allah Hafiz.